If you look at the top of the screen, you'll see that I've drawn you these two diagrams, and if you'll notice, they're actually a little bit different in terms of which valves are open and which valves are closed. And so these are great diagrams to demonstrate systole and diastole. And so what I first want to do is remind you of the heart sounds, which are S1 and S2. And if you remember, between S1 and S2, we have systole, and then between S2 and S1, we have diastole. And we'll finish that over here just to kind of remind you that this is a cycle between systole, diastole. And so in this diagram right here, the heart happens to be in systole. And you can kind of notice the relationship between S1 here and systole. And if you remember, the heart sounds are actually caused by the closing of valves. And so the mitral and the tricuspid have actually just closed. And then when the aortic and pulmonic, labeled A and P here, open, that'll start systole. Now in diastole, in this diagram, we kind of have the opposite situation. So now the aortic and pulmonic valves are closed, but the mitral and the tricuspid, labeled M and T, are now open. And so if you remember, S2 is caused by the closing of the aortic and the pulmonic, and so that'll occur just before the mitral and tricuspid open, as seen here. And when those valves open, you're in diastole. And so I want to give you this logical algorithm to figure out what's going on in a patient with a murmur. So the first question that you want to ask yourself is there a murmur? And if the answer to this is yes, then we move on with more questions. So if there is a murmur, the next question is, when does that murmur occur? So when? And the obvious answer to that would be, well, it's when I listen to the patient's chest with my stethoscope. But we need to get a little more specific. Is it in systole, or is it in diastole? Well, how do we figure that out? So a good method for this is to actually use S1 and S2, because remember, we showed at the top of the diagram up here, where my cursor is, that systole is between S1 and S2. Well, what if the patient's heartbeat is really fast and it's kind of hard to tell which one is S1 and S2? Well, then you can use something like the radial artery. And so you can take a radial pulse on the patient, and every time you feel their artery tapping up against your finger, that corresponds to systole, or the ejection phase of the heart. And so what's closest to that beginning of systole? Well, S1 is closest. And so you'll know that the sound that you hear right when you feel the pulse tap your finger should be S1. So now if you determine that this is in systole, the next question is going to be, what valves are normally open during systole and what valves are normally closed? So let's go ahead and answer those questions. In systole, and you can use the diagram above, what valves are normally open? Well, the aortic is normally open, the pulmonic is normally open, and the other two are closed. So that kind of answers this question. Well, what's normally closed? The mitral and the tricuspid. And so since stenosis is an opening problem, and the only valves that are open during systole are the A and P, or the aortic and pulmonic, that means these two valves, in order to give you a systolic murmur, would be stenotic. And we'll write stenosis here because you would have aortic or pulmonic stenosis. On the other hand, the only valves that would be closed during systole would be the mitral or tricuspid. And so since regurgitation is a closing problem for the valve, this would be regurgitation. And so just to reiterate, this means that if we have a systolic murmur, we have one of four choices based on which valves are open and closed. The same thing can happen in diastole, and we'll ask ourselves the same questions. So which valves are open during diastole? Well, if you look at the correct diagram at the top of the page, the mitral and the tricuspid are open here, and which valves are closed? The aortic and the pulmonic are closed during diastole. And so for the same reasons that we just described before, since stenosis is an opening problem, that means that here you would have mitral or tricuspid stenosis, And here you would have aortic or pulmonic regurgitation. So you may be thinking, okay, well now we have 4 possible choices. Well, how do I figure out which murmur it actually is? So let me scroll down here and give myself a little more space. The next step is to really consider location. So if you've ever been to the doctor and you watch them while they listen to your heart, they usually put the stethoscope in at least 4 different places. And if you look over here, I've drawn a sternum and some of the ribs that go with the sternum to give you an idea for where to listen with the stethoscope. And so one of these locations is in this second intercostal space, meaning the second space in between ribs, and this is called the aortic area. And other people will also say the right upper sternal border, and that's kind of pretty self-explanatory. This is the right side of the patient, so right side, left side, then this would be the right upper sternal border. Another location is again in the second intercostal space, but now it's on the left side. And so this is the pulmonic area. And this is also known as the left upper sternal border. The third place where you usually listen is here. And so this is the fourth intercostal space, and this is called the tricuspid area. And finally, if you haven't realized, we're pretty much giving each valve its own area, so the last one is the mitral area. And this is in the fifth intercostal space, but you'll notice it's a little more to the side of the other ones, or lateral to the other ones. And the anatomic description of that would be the fifth intercostal space in the mid-clavicular line, meaning if you drew a line from the midpoint of your clavicle or your collarbone down your body in a longitudinal fashion, so straight up and down, that it would intersect with this point at the fifth intercostal space. So what I want to do is quickly take you through an example of this algorithm to see that this can actually be pretty logical and easy. So take a second and listen to this murmur. And if you're having trouble hearing this on just your computer, go ahead and plug in your headphones and it'll make the sound a lot better. So the first question is there a murmur? Well, duh, we just heard it. Now, is it in systole or diastole? So let me replay you that murmur again, but a little bit slower. Now you'll realize that you actually hear S1 and S2, and then in the middle, you kind of have all this stuff, or this blowing sound. So what can we say from that? Well, we know that systole is between S1 and S2, so this is a systolic murmur. Now, with our knowledge of what's open and what's closed, we have choices between aortic and pulmonic stenosis and mitral and tricuspid regurgitation. So now, if I told you that you actually heard this murmur in the mitral area, that pretty much gives it away. And so this murmur was that of mitral regurgitation. Now there are other ways of confirming or identifying which specific murmur it is, such as the shape and intensity of the sound and other features, but those are a little more advanced.